Hello, my 12th standard warriors. Welcome to the last session of alternating current. That's with me, Shreyas, your physics master teacher at Vedantu. Hello, Zayed. Welcome aboard. And those of you who do not know me, well, I lead the physics department, JEE division at Vedantu, and I have been coaching and training kids for more than 10 years. And welcome to Enthuse. The reason why I'm here on YouTube is having taught and mentored so many students, and also making sure that these students reach their destination producing top 2-digit all India ranks in JEE mains and advanced. I want to make sure that I spread the joy of learning and you guys enjoy physics like never before and get to learn from the topmost educators in the country or for free on YouTube. So welcome, nice to see all of you out here. I hope you guys are doing fine and you guys are all excited for today's session. Hello Anil Kumar, good evening. And if you have forgotten to smash the like button and hit the subscribe button, please do that right now so that you get our regular updates and you do not miss any of our sessions, so that the way YouTube works is only when you like and hit the subscribe button it shows up in your home feed. So now, I would also take this time to congratulate all our amazing toppers, top scorers, be it CETs, be it board examinations, be it ISC board, be it CBSE board, or even JEE mains. We have produced results everywhere. In fact, you can just see all our results probably by just googling or visiting vedantu.com. And this year, the topmost rank from JEE mains was all India rank 35 from Vedantu, and that's not all. To top it, in fact there were more than 900 students who got below 10,000 rank in JEE mains. That's incredible. More than 900 students out of 10,000 are from Vedantu. So your chances of getting a very good score, your chances of getting your dream college increases when you are in Vedantu. This ratio is very cool. This is something which is unheard of. Hi Lakshmi Balaji, welcome. Anu Srimathi, welcome. Sahil, hello Lakshmi Durga. Good evening guys. So if you are new, do not forget to hit the like and subscribe button so that you do not miss our lectures. And there is a batch starting on Monday. So those of you who would love to study under me, those of you who want to study under teachers like me, those of you who want those amazing preparation guides, those strategies, and those long-term batches along with test series, along with notes, along with doubt solving, and all the other benefits of pro subscription, go ahead, check out the link in the description box. You have 3 versions: Lite, Classic, Plus. In Lite you get everything that you need, but if you want doubt solving then you go for Classic, and if you go for Plus then you'll also get the personal mentorship. All of this for very reasonable rates. It's hardly 3,000 rupees per month, and even if you calculate the whole year cost, you can divide it by 12. It's roughly this much only. You can pay this money in installments as well. So that's what it is. So go ahead, check it out. The link is there in the description box, and also you will get 10% off when you use that link. So let's begin. Yep, Anil Kumar, 9% is from Vedantu. Hi Karnam, welcome aboard. So get ready for some killer JEE advanced questions guys, and let's get started. And here is the first question, but this one, by the way, is a previous year JEE question. So I thought let's do a PYQ also today so that you get a hang of it. So notice this: for the given input voltage, there is a resistor, there is a capacitor. The input voltage is between these 2 points. The output voltage across the capacitor, is best described by which of them? Now, what I'm going to do is look at this voltage in a way which is simple to understand. See, in this time 0 to 5 microseconds, the voltage is 5 volt. So this circuit is actually nothing but as if you have connected a 5 volt battery, you have a resistor and you have a capacitor. That's what it is. It is a charging circuit. So the charge on this will be Q into 1 minus e to the power minus t by tau, and since voltage Q is CV, V is Q by C, so you can see the voltage across this will be the final voltage into 1 minus e to the power minus t by tau. it is going to be very, very similar. So this is from this point to this point. So from this point to this point, you can say this is what is going to occur. Now from here to here, there is zero voltage. That means it's an open circuit, and you know, or you can think this is like shorted, there is no voltage difference at all. So for this particular time, there is no voltage, 0 volts between these 2 points. So that's it. You connect these 2 points, you have this resistor and you have this capacitor. So this is nothing but a discharging circuit. This is nothing but a discharging circuit, and we know in a discharge Q is the original charge e to the power minus t by tau, and the voltage is also very similar, is the initial voltage e to the power minus t by tau. Just looking at these equations, you should be able to predict now what is going to happen to the output voltage. This is the output voltage. Think about it. How will it look like? First, from 0 to some 5 microseconds. So for some time, it is going to charge itself. So how does the charging graph look like? It is an exponential increase. The voltage should increase. Is that clear? Hi Naveen, welcome aboard. Hi T Kalani. Hello Zayad, welcome. Yep. So it should increase. So if you look from 0 to 5 microseconds, everywhere it is increasing. Okay, so all the graphs looks fine. But from 5 to 10 microseconds, because each one of them is 5 microseconds, it should discharge. But it won't discharge completely. You'll be like, sir, why won't it discharge completely? Because if you calculate the time constant, okay, this time constant, which is R into C, R is 1 kilo ohm, that is 10 to the power 3, and capacitance is 10 nanofarad, that is 10 to the power minus 9. So this will become 10 into 10 to the power minus 6, which is 10 microsecond. So 5 microsecond is much less than the time constant. So remember, in one time constant, the capacitor either charges by 63% in case of charging, and in case of discharging, it discharges by 63%. So obviously this time is not enough for even to discharge by even 50%. So that means, you know, what is going to happen, the second part, from 5 micro to 10 micro, the current should decrease. Obviously it cannot remain constant, so this is wrong. You can see that this part, okay, this discharging part is obviously wrong. This can discharge, but it cannot discharge till 0. Look at this, the voltage goes to 0. So this is also wrong, because this is saying it goes till 0 volts. So 0 volts is not possible. It will discharge, but not completely. Okay. Even this graph is wrong, because this is going till 0 volts. It's discharging till 0 volts. It will discharge. You can see it is slightly going down. This graph is slightly going down. And again, after this, what you will see, it will again start charging. So again it will go up. So it goes up, comes down slightly, and again goes up. Again goes down, again goes up. So that's what is happening. So hence option A should be correct. I hope this is clear. Hello Subhanshi Murian. Hello Crack with Google Nath. Is this clear? Is this problem clear? How we have done this? So it is nothing but charging, discharging alternatively. So this voltage should also increase, decrease, increase, decrease, but it won't decrease to 0. So that's why B and D options are eliminated. C option got eliminated because this says the voltage will be constant. That's not permissible. I hope that made sense. Okay, so that's why the correct answer, I believe, should be option A. Yep, it is. It is. Very good, Karman, Vijay Lakshmi. Okay, so let's move on to the next question coming up on your screen. Beautiful question. These kind of questions are very common in JEE, and you should know how to find RMS or average values by using the formulas. Let's do that. Yep, it is indeed a good one. Hello Armigirl BTS, welcome aboard. Those of you are new to this channel, first of all, we call ourselves warriors, and this is Captain Shreyas. And to become a free member for this channel, you know what to do. You go hit the subscribe button, and yes, show your love and support by smashing the like button down there. Now, to find the RMS of this function, go by the definition. What is the definition? The RMS value, okay, the square of the RMS value, so integral E square dt from 0 to t divided by the total time. This is the definition mathematical of RMS. Okay, So here the voltage is this big function, so I have to square it. So A plus B whole square, use this formula, A plus B whole square. So E RMS whole square will be that whole thing square. Think about it. Okay, so you will have 8 sine omega t plus 6 sine 2 omega t whole square dt from 0 to t. Okay, divided by time. Now what will you get? You will get the first term as 8 sine omega t square dt from 0 to t, the whole thing divided by time, plus b square, that means 6 sine 2 omega t whole square dt divided by time, plus 2ab, so that's nothing but 2 into 8 into 6, these are constants, 8 into 6 into 2, these are constants. So what is remaining? Sine and sine. Okay, so sine omega t into sine 2 omega t dt, again 0 to t from divided by time. Now this term and this term you don't even have to integrate, because these are terms which you already know by definition. Okay, I'll give you a small hint. See, if I tell you the voltage was 8 sine omega t, then the RMS value will be nothing but integral 8 sine omega t dt from 0 to t, the whole thing divided by time. This will be the square of the RMS. So when you square it, so this will be the square of the RMS. But we already know what is the RMS value of such a function. What is the RMS value, guys? It is the maximum value by root 2. So basically this is nothing but 8 divided by root 2 whole square. We already know, we have already calculated this integral in our theory classes. Surya, join in, bacha. This is the second question. Probably you can watch the replay of the first question later on. Yep, Rama Kailash, instead of practicing things many times, I would say understand and do it. Even if you do it once, it's okay, but try to do the questions with concepts and understanding. Just doing a problem repeatedly is of no use. Okay, but do those questions which are important multiple times. Rama Kailash. Hello Ankit, welcome aboard. So my point is, by definition, this kind of expression is nothing but the square of RMS, where 8 is the amplitude and 8 by root 2 will give you the RMS value. So over here, if you look at it, this is exactly the same. So this whole expression is nothing but 8 by root 2 whole square. Similarly, if you look at this expression, if you compare it over there, you can see 6 is the maximum voltage. So 6 by root 2 is the RMS value. So 6 by root 2 whole square. Fair enough. Now going to the last term. Now remember, whenever you see sine into sine or sine just omega t or sine to omega t, no matter what you do, when you take one time period, the area under such a graph, okay, for one time period, the total area will always be 0. So the net area will be 0. Sine omega t, sine to omega t, yes, for one time period it will always be 0. That means you just need to put up a 0. You don't even have to integrate this. Yeah, remember this rule. Sine omega t is integral, cos omega t is integral over one time period is always going to be 0, because upper area and lower area is same. It is symmetric function. So now this is simple, guys, to solve, I believe. So this will be 64 by 2 plus 36 by 2. So 64 plus 36, 100 by 2, that is nothing but 50. So the RMS square is 50. So I'll just do that bit over here. So RMS value is root 50. Now root 50 is nothing but 25 into 2 is 50. So that means it will be 5 root 2 volts. That's our final answer. Yep, done. Beautiful question. So the idea behind this question is you don't even have to integrate. If you remember the derivations, if you remember the derivation of RMS, you have already done this. This was done in derivations. I'll just put it over here. This was done in derivation. So I have done this in my first class of AC circuit in general formula for a sine voltage or a cosine voltage. So this is what you should know. So you don't have to actually perform this integration and this one. And remember, the integral of sine or cosine is always 0 over one time period, because upper area and lower area is same. So that simplifies the integration. You don't have to break your head so much. Yep, the answer is 5√2 volts. Okay, so Hari Kishore, the way to join my HCV micro course, it's very simple. Go to YouTube, search for Shreyas Sir Pro. In that Shreyas Sir Pro video, okay, I have conducted one session just probably a few months back. I have explained how to enroll. There is an option, it shows enroll, what to search. If you enter the exact words, then you will be able to see it in your dashboard. Just click enroll, that's it. Okay, it's very simple. Okay, Hari, I think you will be able to do that. If you are still not able to find the video, just let me know after the video ends. I'll definitely let you know where to find that video, just in case. Ankit, the weather is pleasant, I would say. It's cold. Yep, it's very cold, and we are sleeping in the blankets. I don't know about you guys. How is it for you guys over there? Lots of assignments and record writing. I'm not able to concentrate on JEE. Surya, that's the part and parcel of every student's life, but you need to overcome that beta. Remember one thing, every student is encountering the same problem, but they just probably struggle hard, they sacrifice few things, they try to find in some time, and they use some efficient techniques to make sure that they do all these assignments and random things from school in the night, or when you are very bored, so that you are able to concentrate for the rest of the time on JEE syllabus. And join the proper coaching. So when you join proper coaching, your time will be saved, and try to see if you can avoid unnecessarily extracurricular activities and unnecessary functions which are there in your school or probably in your house. Okay, so that's how you can save up on time. Oh my god. Okay, so Hari, you will also get the PDF bacha after the session is over by tomorrow or probably by tonight. Okay, so the easy topics from the term 1 examination. How about this, Meenakshi? Just leave a message after the video ends. I will definitely reply to your comment. Okay, how about that? And by the way, I have also mentioned all the important and heavyweight topics just few days back, Meenakshi. Just look at my session, JEE 2022 strategy, and the term-wise strategy. Which are the important topics and which are the topics you should do? I have just mentioned, I have made a list of all the topics. In fact, I have provided the PDF plus a small session I had conducted. Just you can search for it, past videos. Will you be able to do that, Sri Meenakshi? I'm pretty sure. Yes, Adarsh, you can use sin A sin B formula also. But even if you use that, Adarsh, you will still get the same answer. Okay, so nice to know it is rainy or some people enjoying the weather out there. Wow, temperature is 20 degrees Celsius. That's pleasant, Ankit and Anil. Okay. Oh my god, don't worry, Ankit, you will not come under water. I hope you don't come underwater. Alright, so the instantaneous current in the source, inductor and capacitor are I0, I1, I2, okay, and respectively, whereas the measured currents via ammeter are I0, I1 and I2. Okay, find the relationship between them. Interesting, very, very good question. Let's see how to do this. Okay, now over here, let me just mark everything. So across the source, inductor and capacitor is I0, I1 and I2. Those are the instantaneous currents. So I'll just put it over here. This is, let's say, I0. Let's say through the inductor is I1, and through the capacitor, that is nothing but I2. Now at this junction, okay, at this junction, if you apply Kirchhoff's current law, obviously the current entering in should be equal to the current exiting out at that instant. So I1 plus I2. Fairly simple. So at that instant, whatever current is coming in will be equal to the current which is going out at any instant. But remember, these themselves are actually functions of time. Yep, these are all functions of time. Because this is AC, so the current will keep varying as a sine or a cosine voltage. Hence, you need to be careful for the next part. This is fine. This is at any instant. At any instant. That's why these I1, I2s are instantaneous values. But for the measured values, I0, I1, I2, these are basically RMS values. Now for the RMS, you need to be little bit careful. I'll tell you what. See, the voltage between these 2 points. Okay, let's say this is the voltage. This is the RMS voltage between these 2 points. This voltage is same as this voltage between these 2 points. Do you guys agree? Whatever voltage is there here, the same voltage is there between these 2 points because they are just wires. So it's nothing but parallel. You can think of it that way. This voltage is also across capacitor and is also across inductor. Now, when you had series LCR circuit, the thing which was constant was the current. In all the L, C and R devices, the current flowing was the same. But when you have parallel circuits, the current is not same. In fact, the voltage is same across all of them. So remember the phasor diagram? We used to always draw current first and then relative to current we used to draw voltages for series LCR. Now you cannot do that because the current is different. So what is same? Voltage. So start with voltage and accordingly relatively mark the currents. That's the logic to be used. So let's see how to do this. So first of all, the voltage, I will show it over here. The voltage is same for parallel circuits. We know this. So voltage is same for parallel circuits. So accordingly we'll start marking the current. Okay. Now there is no resistor, there is only inductor and capacitor. So let's say this is I1, this is I2. For an inductor, try and recollect, the voltage was always ahead of the current. The voltage was always ahead of the current for an inductor. So voltage is ahead of the current, that means voltage is here, current is over here. So this will be IL. Think about it. So this will be IL. Yes, that's what it is. Now, for a capacitor, the voltage was always behind the current. So current is ahead. So current across the capacitor will be somewhere over here. So this will be IC. Yup, that's right. Now IC and IL both are opposite, but they will not necessarily cancel each other. It depends on many things. So their resultant current, okay, the net current. So the net current, okay, will be nothing but, you know, IC minus IL, whichever is bigger. So it will be nothing but IC minus IL. I do not know which one is bigger. So I'll just put a modulus symbol over here. So what is this net current? That net current is nothing but I naught. Yeah, that is nothing but I naught. So instead of I net, I'll just put I naught over here. So that's the final current, RMS value. That's what is important. I hope this is clear. Akshay, I think I just mentioned how to join HC Verma Solution micro course. Just leave a comment after the session ends. If you are not able to figure it out, I'll reply to your comment after the video ends. Okay, I'll share you the link, etc. Whatever details are needed. I hope that is clear. Okay, chalo. So the instantaneous currents will add, but the RMS's current or the reading shown will subtract to give you the net current. That is very, very opposite to the gut feeling. Many people think I1 plus I2 is I naught. That's wrong. I1 minus I2 is basically I naught. So this was actually the net current. If you forgot, this was the net current, and therefore I naught will be modulus of I1 minus I2. That's what it is. Okay, cool. So let's go to the next question, and here it is. The two identical incandescent light bulbs are connected as shown in the figure. So now this is again a parallel circuit. When the circuit is an AC volt, where in the circuit I think there is an AC voltage source of some frequency, which of the following observations will be correct? Okay, this is straightforward. We can do that. Okay. Pravansi, which graphics, bacha? I'm not sure which one are you talking about. All right. And here we go. Now for the for figuring out which bulb will have the glow and when will it have, I think we should start with the phasor diagram. I hope you can see both of them are parallel circuits. The same voltage is there across both of them. Think of it like two independent LCR circuits. This is one LCR circuit, this is another LCR circuit. That's it. Okay. What is same across both of them? Voltage is same. So start with the voltage first. So the voltage is same for both. The voltage is same for both, but the current will not be the same. That's the whole idea. So if you think this is a capacitive circuit, RC circuit is there. This is nothing but capacitive. So in case of a capacitive with capacitor with resistor, what just happens? Try to recollect. Capacitor with resistance, it's always the current which leads the voltage. Try and recollect. The current leads the voltage, capacitor's voltage is below, and the current is ahead of the capacitor's voltage. So if current is ahead of the capacitor's voltage, so you should see something like this. So this is the current passing through the capacitor. This is not 90 degrees. The reason why it is not 90 degrees is because there is a resistor also. So whenever you have a resistor, try and recollect, guys. We have seen this. So you always have this VR, you have this VC. So this is the total voltage across RC circuit, and this is where the current is. So the current is going to make some acute angle with the voltage. So voltage is here. So the current, I'll have to just turn that diagram like that. Okay. Now if you use the same logic for LR circuit, the current will be behind. So you can see the current phasor across the LR circuit. Okay, this is probably, I can put LR and this is RC circuit, is going to be somewhere here. This clearly tells me that there is definitely some phase difference between the current in bulb 1 and bulb 2. So the current flowing through bulb 1 and bulb 2 is not simultaneous. What it means is that, see guys, if you draw the current versus time graph in bulb 1 and bulb 2, in bulb 1, if it is like this, then in bulb 2, maybe it is like this. There is some phase difference. This difference is coming because of this angle. So in bulb number 1 and in bulb number 2, obviously there is some phase difference. That means their currents will be maximum at different instants. So they will glow. Let's say bulb 1 has glowed maximum. That time bulb 1 or the other bulb might not be maximum. Once this current decreases in one of the bulb, the second bulb's current would be more and it would reach maximum. So it will be alternate. So the glow in the bulbs will be alternate. That's why answer is A. Yes, IIT JEE 2021. I hope this is clear. Hi Naveen, yes. Yep. So the idea behind this question is that the currents are not in the same phase. So the currents will keep changing and the glow completely depends on the current. So if you are wondering about this glow completely depends on the current. More current, more glow. Because the brightness of the bulb is basically dependent on the I squared R heat which is produced. That's what it is. Yep. Why not D? Bulb 1 will blink and bulb 2 will be on constantly. No, both the bulbs will blink. Yep. So this will go on, off, on, off. So the current is continuously increasing, decreasing, increasing, decreasing. So both the bulbs will blink. So hence D option is wrong. Ankit, I hope this is clear. Yep, Anil, I know tomorrow we are going to have a motivational casual session. Yep. So which one will be brighter? Well, that is difficult to say because nothing has been told about the bulbs. Whether the bulb 1 has more resistance, whether the bulb 2 has more resistance, we do not know anything about it. Number 2, I do not know the values of L and C. So that's why I will not be able to compare which bulb is more bright or which one is less bright. I cannot say that. So both the bulbs will glow with the same brightness is something which cannot be inferred from this piece of information. That's what it is. Okay. Vicky, I have already completed term 1 syllabus if you notice. Oh, by the way, if you want the PDF, please join the Telegram group, guys, because I'll be sharing all the details. Okay. So I have completed the term 1 syllabus, and once your term 1 examinations are over, we'll get going with your term 2 syllabus as well. Yep. So Vicky, for state board examination, it will be little bit extra because these are mains plus advanced sessions. For state board, the kind of sessions needed will be very, very different. But conceptually, yes, these sessions will definitely help you get, in fact, very thorough and in-depth understanding of the topic. Okay, chalo. Let's get going. Yes, IIT JEE 2021, it will depend on XL and XC values. Next question coming up on your screen. If the total charge stored in the LC circuit, is Q. Okay, let's say this charge stored was Q initially. Then for time more than 0, the charge as a function of time, okay, actually you have to find the charge as a function of time and the differential equation of the oscillation. Very interesting. So first of all, realize that this is nothing but a LC oscillator circuit. This is nothing but a LC oscillator circuit, and in LC oscillations we know the charge as a function of time is the maximum charge, okay, into sine of omega t plus phi. Phi is the phase difference, and this value of omega is 1 over root LC. This was your standard formula. Everybody remembers this. Now just look at what is given in the question. So initially the charge stored was Q. So there was at t is equal to 0, the charge over here was plus Q, this is minus Q. This is completely charged. The current would be obviously 0. The moment you connect this inductor, what will happen? This charge will keep reducing. So after some time this might become just plus Q. This will become minus Q. So what has happened? The charges have begun to flow inside this inductor. And so there is some current which is there in this circuit. So again you will see the charges will get reversed and the current will again reverse, and these charges will keep on flowing in opposite directions. We have studied this in EMI chapter as well. Yep. So guys, the idea behind this question is that the charge will be a function of time, and we know that function. Use these initial conditions to solve the problem. So from the initial conditions, the initial charge is Q. This is nothing but Q max, okay, into sine. Time is 0, so just put 0 plus phi. From this, what are we going to get? Well, obviously, you know, Q is equal to Q max, that's obvious, and 1 is equal, because this is the maximum charge stored, 1 is equal to sine of phi, therefore phi is equal to pi by 2. Very simple. So from this we have got our final equation. So the charge will be nothing but Q sine, okay, omega t. Omega is nothing but 1 by root of LC into t plus pi by 2. This is our charge as a function of time. Some people might also prefer to write it as cosine function. That is also okay. So Q sine of theta plus pi by 2 or 90 is cos. So it will be cos t divided by root of LC. This is also fine. This is also fine. You check the options. As simple as that. Alright, Shailendra, you guys understood it. Now going to the next part, differential equation. What is the differential equation, guys? Oh, well, you need to remember simple harmonic motion. If you remember simple harmonic motion, this is going to be a cakewalk. Okay, so what was the simple harmonic motion differential equation? It looked something like this. Okay, kx plus m d square x by dt square is equal to 0. This is how it looked like, if you recollect. And I had already told you that mechanics and electricity are related to each other. If you remember, K, which is spring constant, is similar to capacitance. So K is similar to 1 by capacitance, I had told you. Mass is similar to inductance, and X is similar to charge. These are the direct transformations that you can do. Spring constant is equivalent to 1 by capacitance, mass is equivalent to inductance, and X, which is position, is similar to charge. Every equation works if you remember this, and this will always help you solve the problem in an easy manner. So instead of K, what are you going to put? You are just going to put 1 by C. Instead of X, you are just going to put Q, plus instead of M, you are just going to put L, and here you are going to put d square Q by dt square is equal to 0. If you don't like the C below, you want to take it on the top, no issues, just bring it on the top. So Q plus LC d square Q by dt square is equal to 0. So this is my second answer. This was my first answer. So both answers are done, and that's how you get the answer. So you can compare and simplify the problem. You don't have to break your head so much. Hello Amu, hello Anvit, hello Pia, welcome aboard. Join in, bacha. Okay, If you start doing math, I don't want to switch up to the next thing. So Ankit, you should have timelines. You should probably, think of setting up an alarm. Okay, now once the alarm rings, okay, now I need to move on to the next subject. I know certain subjects or topics could be very, very interesting, or it might be your favorite. You can set alarms. You can also remind somebody to ask you to do something, and never start with your favorite subject. If you're doing daily studies, probably start with another subject, because then if you start with your favorite subject, you will never feel like switching over. So start with whatever, physics or chemistry, and then once that topic is done, then move on to other subjects. I hope that is clear. Sports and studies together, it's very difficult, Zohaib Ahmed, if you are preparing for JEE. Some people do it. You might have heard some toppers saying, yeah, I did this also, I did that also, but that is very exceptional cases. There are some people who are God gifted, who can do multiple things, who can do multitasking very easily. But not everybody is God gifted. So for those of you who think that you cannot multitask and I cannot manage time efficiently, I take some time. Guys, the only substitute is hard work and complete sacrifice. So sacrifice and hard work will help you get through this tough seas or rough seas very easily. So if you want to get into IIT, if you want to get into top college and top branch, you want good ranks, so you need to do that, bacha. Okay, chalo. So that's the answer for this question. Moving on to the next one coming up on your screen. Yep. Okay, chalo. There we go. Look at this question, guys. Beautiful question. It's a series LCR circuit. The voltmeter across the inductor reads 460 volts and across the capacitor reads 400 volts. The resistance is 50 ohms. The power factor, impedance and the reactive power, if the source is 100 volts, 50 hertz. Okay, I'll tell you what, I had mentioned this before also, that AC circuits, most of it is nothing but vectors, phasors, that's it. More than formulas, it's more about solving these vector and phasor diagrams. So across the inductor I know the voltage, and across the capacitor also I know the voltage, and I know the total voltage, which is the source's voltage. So I think I should start with phasor diagram. Okay, so this is my VL, this is my VR, this is my VC, and this is my total voltage. Let's see what and all do we know. The voltage across the inductor, this is 460. Voltage across the capacitor, that's 400. This voltage, the total voltage is 100. So this is 100. Now from this you can clearly see 460 is on the top, 400 is below. So the difference will be exactly this one. So this difference will be 460 minus 400, which is nothing but 60 volts. If this is 60, we can easily find this one out, because this is a right angle triangle. So we all know that 100 square, which is the hypotenuse, it will be nothing but 60 square plus VR square. 10, 6, 8. It's a Pythagorean triplet. Yeah, so you should be able to guess this. VR will be nothing but 80 volts. As simple as that. That's the first answer, but I don't think I need that. Okay, I'll just keep it like this. Okay, fair enough. I got the voltage across the resistance. Oh, now I know what to do. This angle is phase difference between the net voltage and the total current. Isn't that right? So in this triangle, if you use simple geometry, you can get power factor. The power factor, remember, was nothing but cos phi. And what is cos phi? Cos phi is this divided by this. So it will be nothing but 80, which is adjacent, divided by hypotenuse, which is 100. So it will be nothing but, okay, I'll just put it over here. So 0, 0 goes. So 4 divided by 5. That's our first answer. 4 divided by 5 is the power factor. Done, done, done. Hariya, thank you for all the love, bacha. Welcome aboard. Hi, Ved Prakash. Hi, Praniti. Join in, bacha. Now, to find the impedance, draw the impedance triangle, the impedance phasors. Just like you have voltages, you have resistances. So, the XL value will be here, XC value will be here, the resistance will be here, the impedance will be here, and this will be phi. Now from this geometry, you can clearly see the value of cos phi will be adjacent by hypotenuse in this triangle, adjacent by hypotenuse. But I just figured out what is the value of cos phi. It is nothing but 4 by 5. Yes, it is nothing but 4 by 5. This will be equal to R. Is R given? Yes, 50 ohms. So this is nothing but 50 ohms divided by Z. So therefore, Z will be 5 into 50. That's 250 divided by 4. Well, so therefore, Z value will be equal to 125 by 2. 125 by 2 is nothing but 62.5 ohms. That's the final answer. Yep. So Z is also done. Everybody clear about this? So easy. Hi Sunny Yadav, welcome, welcome. Hi Dipanshi, good evening all the new warriors. In case you have forgotten to subscribe, please hit the subscribe button so that you do not miss the class next time. I always come over here at 7:30. Now the last part, the reactive power. I had told you about this power triangle and I had told you about the reactive power as well. So probably I'll just get rid of all these things. I don't need this anymore. Okay, so the reactive power formula is Vrms into Irms into not cos phi, sin phi. Actual power is cos phi, reactive power is sin phi. I had told you about this in the power triangle lecture which I conducted just few weeks back or probably few days back. This was taught. What is the voltage across the circuit? It is 100. That's the RMS value always. 100. What's the current? Oh, current I do not know, but I know current. Current is total voltage by impedance. So the total voltage by impedance. Impedance is 62.5, which was nothing but 125 by 2 into sin phi. Acha. Look at this. I just know the value of cos phi. Don't I know sin phi? Because the value of phi actually will come out to be 37 degrees. Correct? So what is the value of sin 37, guys? The value of sin 37 will be nothing but 3 by 5. 3 by 5. So put that 3 by 5 over here. So this will be nothing but 3 by 5. Now it's just a matter of solving this. So just see what you get this as the answer. So it will be nothing but 100 into 100 into 3 into 2. The whole thing, oops, 1000 over here. That's 100 into 100 into 3 into 2. And this is 5 into 125. So 125 is nothing but again 5 into 5 into 5. So a lot of 5s out there. So 5, 5, 25, this will become 4. This 5, 25, this will become 4. So 4 4s are 16, 3 2s are 6, 16 6s are 96. So 96 watts. That's the answer. Yep, 96 watts. Did you guys get it? Whoa, Ria, you're ready for the coffee session. Please do not forget to get your coffee and your cookies and your bread and your chocolates for the session. It will be amazing. You can just sit back, relax. First time probably, or very rarely you get that chance that you don't have to sit with calculators, with your books and with your notes for my session. That day you can just relax in a park or maybe on your couch or in your bed and watch the session. Oh, I do not know if somebody is already doing that for even an advanced session, relaxing on a bed and watching Sir solve. Sir is solving. I just have to watch Sir to solve. That's it. My job is done. I will get to know everything. Okay, chalo. Let's get moving to the next question. That's the answer, guys. And moving on to the last question of today. Okay, so let me know if you guys are ready. And this is the most brilliant question, guys. Oh, I look a bit faster, man. Mama do bari. Oh, Mama do bari. What is that name? Riya is on diet. Okay, chalo. Koi baat nahi. Let's get moving. The fluorescent lamp, commonly known as a tube light, employs a choke coil, an inductor and a starter. In normal operating mode, a choke coil is in series with the tube that behaves as a resistance and the starter as an open switch in parallel with the tube. In a particular fluorescent lamp, the voltage is n times more than that of the tube. If the choke coil is an ideal inductor, how much capacitance will you connect in parallel with the lamp to make the power factor unity? Okay, let's try and understand the diagram because no diagram has been given. Okay, let's do this. Now, first of all, this is a lamp which is nothing but a tube light. Okay, we don't have to break our head over it. It has a choke coil, which is nothing but an inductor. Okay, choke coil is nothing an inductor, and it is an ideal inductor of inductance L. What is the meaning of ideal inductor? An ideal inductor does not have resistance of its own. So the coil is just a wire, no resistance. So let me just think of just an inductor. This is an inductor. And a starter. There is also a starter. In normal operating, the choke coil is in series with the tube. Oh, interesting. Look at this. It is in series with a tube that behaves as a resistor. Okay, so it is in series with a tube which behaves as a resistor. So I'll just call this as a tube. This is your choke coil. Okay, and the starter as an open switch in parallel with the tube. Okay, the starter as an open switch in parallel with the tube. So this is our starter. That's the simplified diagram in normal operation. Okay, and now this whole thing. Oh, by the way, what's the use of this starter if it's an open switch? It's as good as it is not there, right? It's as good as not there. Okay, so anyways, how much capacitance should you connect in parallel with the lamp? This whole thing is the lamp, by the way. If you are wondering what is that lamp, okay, this whole thing is our lamp. Okay, this is our lamp. So this entire thing is our lamp. And what you have done, you have connected a capacitor in parallel like this, so that the total power factor is 1. Okay, the total power factor is 1. That's what is given in that particular question. Beautiful. So I hope this is clear. Hi Jania, welcome aboard. Looks like some people have their own chat box going on over here, like Nanu and Ved Prakash. I don't know, some independent chat going on over there. Guys, there is Telegram, there is WhatsApp. You can download that for free. You don't have to come on YouTube. I don't know why people come on YouTube to chat. Is there some secret which I don't know? Okay. Anyways, now let's try to draw the phasor diagram. Guys, this looks to me like a LR circuit in parallel with C. Okay, this is the external circuit. Okay, so the current will come over here, it will get divided, and it will come back over here. So this is nothing but a parallel circuit. So this is a parallel circuit where you have LR in one branch and capacitance in the other branch. And what is same? The voltage is same for both. Yep, the voltage for LR as a whole and capacitor as a whole is the same. So let's start by drawing the voltage. So the voltage phasor will be over here, correct? The voltage phasor will be here. Capacitor is easier to draw, so let's start with capacitor. Well, for a capacitor, the voltage is always ahead, the current is always ahead of the voltage. So current is ahead, so that means I can easily show the current in that capacitor over here. Just check this out. This is the current in the capacitor. Now, for the LR circuit, you need to be a little bit careful. For LR circuit, we all know that, the voltage is always ahead of the current. The voltage is always on the top and the current is on the horizontal, so voltage is ahead. So the current will be somewhere in this direction because of that resistance. Okay, so the current will be somewhere over here. This is the current in the LR circuit. This is one thing. Let's say this angle is theta. Now, the most important thing that you should understand is that the power factor is unity. That is what is given. That means when you add these two currents, by the way, this current will have two components. If I just draw it over here, there will be two components of this current. Yep, this current will have two components. One component here, okay, that will be the cos component, and the other component here will be the sine component. If this component and this component cancels out, this is ILR sine theta component. If it cancels out, the total current will be only this much, the cos component. So this will be ILR cos theta. this will be the total current. Now, why am I saying these two should cancel out? The reason is, when these two components cancel and the total current comes here, the total angle between the current and the voltage is 0. The total phase difference is 0. That's why I'm saying these two components should cancel, and I have been repeatedly telling AC chapter is at the end of the day vectors only. Just treat these quantities like phasors. Phasors are vectors. That's it. See if you guys got it. See if you guys got it. Did you guys get it, guys? Why I have cancelled this component and this component? Very, very important. See if you guys understood this. Okay. Now, once you understood this, this current can be written down. Oh, wait a minute. Not this current. The voltage across the inductor and the voltage across the resistor can be added in a very systematic way. Okay. Look at this. This is the current in this branch. And the same current flows through the inductor and the resistor. Correct? The same current will flow through the inductor and the resistor because both of them are in series. So how about thinking about the voltage across this resistor and inductor separately in this phasor diagram? We all know voltage in a resistance and the current are always in the same phase. Okay, so they are always in the same phase. So the voltage in that, resistor will be just like this, as simple as that. Okay, nothing great about it. But voltage in an inductor is always ahead of the current. It's always ahead of the current by 90 degrees. And the total voltage vector addition, VL vector and VR vector, will give me the total voltage. Agreed or not agreed? Think about it. Think about it. Anthony, I have already made some videos, just check it out last week. Voltage across the inductor and voltage across the resistor together will give me the total voltage across this. This total voltage I already know. This is that V. That V is the total voltage across the circuit. In case you forgot, this is my V volts across this entire circuit. So can I not say that the inductor, which will be ahead, you can see inductor's voltage is ahead of the current by 90 degrees, and their vector addition will be that blue line, which is this V value over here. See if you guys got it. See if everybody is getting it. This point is very, very important. This is a very crucial problem. It's not so easy. So that's why we are taking some time to solve this. I want you to understand each and every step of this question. Now comes the best part. Okay. It's given in the question that, where is it? The voltage drop across the coil is N times that on the tube. This voltage is N times that of the tube. So VL is nothing but N times of VR. Interesting. Okay, fair enough. Now let's start actually solving the question. These two are equal. Remember, I just told you IC and ILR sine theta are equal. So let's start doing it. Probably I'm not going to need it, but I'll just erase this part. Okay, so I think I don't even need this now. I'll just remove this. Okay, so IC should be equal to ILR sine theta. Okay, ILR sine theta and IC should be equal. They should cancel so that the resultant is here. Okay, this is only so that power factor is 1. So current and voltage, the phase difference is 0. The phase difference between them, the total current and the total voltage is always 0. Okay. Now what is the current across the capacitor? The current is nothing but, think about it, it's the voltage, because the voltage is the same, divided by, okay, divided by the reactance, because V is IR, so I will be V by R, reactance will be XC. The current across the LR circuit is same across inductor as well as resistor. So let's keep things simple, na? Let's keep things simple. So how about taking the current in the inductor? So ILR numerically is also current across the inductor itself. This is one and the same thing because the same current will flow through both of them. What is sine theta? Look at this diagram. What is sine theta over here? Very interesting, guys. This is theta. From here you can easily see V is nothing but, okay, I'll just put over here, V is nothing but VL square plus VR square, and VL was N times VR, okay, N times of VR. So that means it will be N square VR square plus VR square. So V will be nothing but N square plus 1 under the root, and VR will just come outside. So the total voltage is N square plus 1 times of VR. So sine theta will be opposite by hypotenuse. Sine theta is nothing but opposite by hypotenuse. So just use that and see what do we get. So opposite is NR. Okay, so it is NR. Oops, sorry. It is N times of VR, my bad. N times of VR divided by hypotenuse, which is VR into this whole value. So VR into root of 1 plus N square. Interesting. Now what is IL? What is IL? Think about it, guys. The current across the inductor. Interesting. The current across the inductor. Can I do something over here? Just think. Can I do something over here? Yes, current in that inductor is nothing but the voltage across the inductor divided by inductive reactance into N. VR gets cancelled by root of 1 plus N square. And over here, what do we get? Yes, I just have V by XC. Acha. Now what is VL? Oh, I know what to do. V and VL. V and VL. Just look at this, V and VL. I can see clearly some sine theta coming up over here. V sine theta is VL. I don't know whether you saw that. So V by XC is as it is. VL is V's sine theta. So this is V sine theta. This is divided by XL, and this will be eta divided by 1 plus eta square. Very good. So again you can see this V and this V got cancelled. I just have to substitute the values of XC and XL now. Okay, let's do that. XC is nothing but 1 by omega C. XL is nothing but just nothing but omega L. Sine theta, I just figured it out over here only. Just remember, sine theta was just this value, N by root of 1 plus N square. So just put sine theta as N by root of 1 plus N square. Again, the same thing will come over here, root of 1 plus N square. Okay, now the next step will be, okay, just rearranging these terms. So I think I wanted capacitance, right? So omega C goes on the top. Okay, I have N square on the top. I also have 1 plus N square root. So root goes off. So 1 plus N square as it is, and omega into L. But I just wanted C, right? So C will be nothing but N square divided by 1 plus N square. Omega into omega is omega square into L. So that's our final answer. Yep, done. See if this makes sense. Warriors, are you alive? Are you alive? Please let me know. Okay, what a brilliant question, guys. This was mind-blowing, right? What a brilliant question. So many concepts used over here. After this, probably will never crib about AC. Now, I would ask you to solve this problem on your own again. And if you get stuck, play that part which you did not understand and stop. And again start it on your own. And again, wherever you get stuck, again try to do it. Again, after a few days, try to do this kind of question. So these kind of questions I will do, you know, in my numerical course. If you want more questions like this, by the way, this is the answer. This is the course which I am conducting for the 12th standard students. Okay, not exactly these level problems, everything won't be this level. There will be variety of questions which will improve your mind. And if you want to do these kind of questions and if you want to improve your score, please join the pro course, that is the magnetism, EMI and AC. It is for free of cost for everyone. Yep, you can, it's only on Vedantu platform, it's not on YouTube, it's on the Vedantu Pro subscription. If you are a pro member, it's for free of cost. The course starts on 4th of October. This is what I am conducting. Okay, that's my course. These are the problems, these questions, you will not find it so easily anywhere. It's not so easy to also solve it. So with my inputs and my techniques, you will see some really hidden insights which will improve your skills for solving the problem. So if you want to join it, please go ahead now. Not just that, you will also get my other micro courses. You will also get the option to learn in English and Hindi for any long-term batches that you plan to do. KVPY, yep, that is also available. Again, everything under one cost. Tests, assignments, parent-teacher meeting, you name it, guys. Everything is included. So all you need to do is, if you're watching this video right now, just go ahead, all right, and go down, 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 down. You will see there is class 12th subscription available. If you just want CBSE, then click on this one. But if you want JEE preparation, this is the one you should look forward to. Not only will you get your full long-term batch, but topic specific and micro courses conducted by different teachers, revision, mock tests till the end, JEE Mains and Advanced, everything. You will see there are 3 options for you: Light, Classic and Plus. Light has everything what I told you. Now, if you want doubt solving on the mobile app, you go for the Classic version. And when you go for the Plus version, you get a personal mentorship as well. So all of this at a very reasonable rate. 36,000 is the total 1 year cost. But if you break it down per month, it's roughly 3,000 when you use my discount coupon code SHHPRO. And you can also opt for EMI as well. The same thing is also there for Classic and Plus version. So most of the students usually go for the Classic version. And if you feel that you want to try it out for 1 month, you can try for 1 month as well. Or you can buy the complete course by paying the entire amount or on EMI option as well. And you will get these offs and these offers when you use this discount coupon code as well. This is the maximum offer that you can get anywhere. So that's something which you should look forward to. So I'm really eager to see all of you guys in my pro course, and I really want you to improve on your problem solving skills. So Anil, that just means bye bye. Yep. So the Zero to Hero Nikhil will start again next year for the 2022 batch. I'm very good, Ankita. Thank you very much. Hello Mithuna. Yeah, the session is almost about to be over. Hello Chander. Yep. So if you want to get notified about my next sessions, you need to please hit the subscribe and also the bell icon, and also hit the like button to show your love and support for this channel. Thank you guys for tuning in. And this was Shreyas here, your physics master teacher. And please keep studying. Do not worry. I am here. We'll fight till the end. Take care. Have a great time. Hasta la vista.